All right, guys, we're going to start. I'm going to put 7.6, 7.7, and 7.8 on the board. I'm going to give you lectures, examples. Everything you need for the next couple weeks are in this packet. I will have to reteach or teach lessons 8, 1 through 8.7, 8.8, and then 8.9. We'll do that kind of as we go, but we'll kind of do it 2 to 3 weeks at a time. You're going to be picking up this packet. I'll explain it when I shoot you a text. You've already gotten that, but I want to show you exactly what's happening. The first thing is an assessment. Please do this by yourself, show all of your work. The second is going to be the notes to what we're doing today. So the first example is going to be example 1 on there. There's a few you'll have to write down because I wanted to give you a couple extra. Then I give you the homework examples, or, all the solutions to 7.6, 7.7, and 7.8 of how to do it, which ones to use, so on and so forth. And then the rest of this stuff is going to be chapter 8 stuff. We won't use this yet, so we're going to focus on chapter 7. But once we get to this, I want to make sure you already have it, so when I start videotaping, you'll kind of have this schematic of, I'm going to say, all right, we're going to talk about the geometric series and the harmonic series first. Then we'll do the P series and the K term test. I'll show you examples on the board. I'll walk you through, hey, the procedure. Hey, when I see this, this is exactly how you should do it and how you should proceed. So you're going to be getting all this stuff. Then I will ask you to collect it. I'll send you a text telling you when you can do that. All right? Thank you. Okay. So now what I'm going to do is I'm going to teach you 7.6, which is called Integration by Table of Integrals. Before you left, I gave you this nice little packet because Mr. Strickland, Mr. Pelker told us make sure we're ready to teach through e-learning. So all of you should have this packet. If you don't, it's in your book. It's actually A27 in the very back. So the book is online. It's on my Google webpage. So remember, it's Y10bin is going to be the code if you forgot that. Hopefully all of you are signed up, ready to get in. But if you don't have this, you can always look at it online. Once again, I walked you through the ideas of this of, hey, if you're going to use the forms of integrals using u to the n, we use these first couple. Then on the second, it says a plus bu. Third little section is going to be involving quadratics. A plus ux plus cx squared. So what I want to talk to you about this is we're going to walk through examples. I'm going to show you where to find them, which ones to use. And once again, the only difficult part about this is going to be the u substitution. So if there's like an x out front and I'm talking about an x squared, we need to put another 1/2 to compensate. That's going to be the hardest part about this. Some of you are going to look to this and say, why didn't you teach me this earlier? Because a lot of the integration by parts and some of the harder things we've done are actually in this packet. So we're going to go through this and see what's happening. All right, so the first example, which if you get this 4-point out, learning objectives, integration by a table of integrals, this is the first example on here. What I want to talk to you about first is, okay, how do we approach the problem? Well, the key thing is I want to kind of look at what's my main argument. Well, my main argument is going to be something raised to a power most of the time, unless it's an ln or an e or an arc sine, which we'll give you some examples of some of those as we go. So we want to look at a plus bu. So what we do is we go to the formula sheet and I want to say, okay, I want to look at a plus bu. So when I come here, I'm at the section of 3 through 13. It's on the front page. So if you look, it's a plus bu, and then I want a u on top. Okay? Well, if you look to number 4, it's a plus bu squared. So whenever doing the homework, the first thing I want you to do is put which of these integration tables we're going to use. I want to use number 4. In this case, what I do is I say, okay, a is 2 and b is 4. So go ahead and designate what your variables will be. Sometimes there will be a c if you have a quadratic. And then what you do is you just plug into the formula. So number 4 is 1 over b squared. So to answer this, you put 1 over 4 squared. So it's 1 over 16. And then it's a over a plus bu. So it's 2 over 2 plus 4x, and then it's plus ln of the absolute value of 2 plus 4x in the parenthesis plus c. So this is what the answer will be, but make sure you tell me that we use number 4. So once you designate A and B, all you're going to do is you're just going to plug them right into the formulas. Right? So the next one, what we're going to do is we're going to look at the integral of the x squared over the square root of 1 plus 4x squared. So the key to this is, hey, where do I start? Well, you start with the square root, okay? And if you start with the square root, this is going to be the one that when you look at this, we want to find out, okay, I want to find out where the square roots are in the table. So if you flip, it's of the quantity of u squared plus a squared or a squared plus u squared. Because I can write this as 1 squared plus 2x quantity squared. So if I go down here, I need to find which one. So I'm in 26 through 36. So I need to find out, hey, which of these do I want to do? Well, in this case, I have an x squared up top. So you go all the way down, and if you look at number 34, it's set up exactly the same. Okay? Now in this case, your a is going to be 1 because it's 1 squared. But your u in this case is going to be 2x. And remember, the only thing that we have to do is, if u is anything other than x, we need to worry about the compensation. So I'm going to follow number 34's rule. But what I need is, because this is a 2x, the derivative is supposed to be out front. Because there's no 1/2, you need to start off with the 1/2 there for the compensation like we've done so many times. Now from here, we do the formula. Well, if you look at number 34, it's 1/2, then it's the parenthesis, then it's u, which in this case is 2x, then it's the square root of u squared plus or minus a squared. So in this case, since it's a plus in there, it's u squared plus a squared, which is going to give me 4x squared plus 1. And then it's going to be minus, because we follow the same rules on the top. It's a squared, well, a squared is just 1. Then it's ln of the absolute value of u plus, then it's the square root of the same thing, which is 4x squared plus 1. And then we have our plus c. So the key to this is going to be, hey, I need to know which rule to follow. Then I just need to set my variables equal to whatever they end up being in the problem. And then we just substitute in. Once again, the only tricky part is don't forget this 1/2 for the compensation if something is other than x. Okay, let's go to the next one. Number 3. Well, once again, the problem is where do I start these problems? Well, look for the main part of the argument. The main part of the argument, the hardest part is going to be the square root. So I want to look to my table and say, hey, where are the square roots? Well, if you look to 16 through 22, it's the square root of a plus bi. So it's the square root of a plus bu. Well, the thing is, if I rewrite it like this, -1 plus x, the only thing is my a is -1, which is perfectly fine. So if it's not written in the same order as what we need, we just change it to make sure we get all the variables straightened out here. So if we look, I have the square root of -1 plus x, but I have an x out in front. So if you look at that, that's going to end up being number 17. So if we look at number 17, the key is there's 2 of them. And it says, hey, if a is greater than 0 or less than 0, for us, a is less than 0, so we want to use the one on the bottom. So you go to it and you say, okay, it's 2 over the square root of -a. Well, a is just going to be -1, so you plug that in there. Then it's arctangent of the square root of a plus bu, which is -1 plus x, all over the opposite of a, which is 1, and then you have plus c. So once again, the key to these is to figure out which section do I need to be in to figure out what number, and in this one, the square root is going to be the key, and it's the square root of a number plus x to the first degree. So a little different one is going to be number 4. So if I said, all right, let's integrate this. We don't have any basic rules to this, so I need to say, all right, where can I start? always start with your most difficult part. Okay, it's the square root. Hopefully you can recognize that these things are squared. This is really the square root of x squared minus 3 squared. If you can recognize that, then you can go through and say, hey, I want to know the square roots of x squared plus 3 squared, which means I'm in the section of 26 through 36. Well, there's one x out front, so I want to find on here where there's an x out front. Well, the key to that is this. If you set, this is x squared squared. If you set u equal to x squared, du is 2x. So this x is really here because of the chain rule. So that's going to be the tricky part I told you. So we really don't need to find this x out front. It's part of the derivative of this. So what I'm really looking for is the square root of u squared minus a squared. All I need is to compensate is for a 1/2 out there. So I put this 1/2 out here, and now I'm going to be, all right, I can look at this, and it's going to end up being number 26, which is the square root of u squared plus or minus a squared. So if we look at 26, there is another 1/2 out front, and then it's u, which for us, u is going to be x squared. Then it's the square root of whatever this turns out to be, which was x to the 4th minus 9. Then it's plus, it's a squared. Well, a is 3 in this case, so a squared is 9. And then it's ln of u, which we just said was x squared, plus the square root of x to the 4th minus 9. And then we have our constant of integration, which is plus c. This is what the answer to this one would be. This one was super tricky, and I put this in here because some people are going to be like, oh, that x is out there. Well, if your argument u is x squared, you're going to have an x out here. So we just kind of say, hey, that's just part of my u substitution, and I'm just missing a 2, so I need to compensate for a 1/2. Okay, so for the last one, I want to throw one of these on here. What do I see? I see an e. All right, so if I see e's, I look in my table and I'm going to be like, okay, where do I find e's at? Well, if you go to the very back page, 81 through 86 is if you have e to anything. Well, number 84 is when you have this. Now, once again, it's going to be 1 plus e to the u. So I'm going to use number 84 in this. But the key is if u is negative x squared, that means du is negative 2x. That's why that x is up top. So I have my x, I'm missing a negative 2. So I just need a negative 1/2 in front. And now I'm going to do number 84. Well, number 84 is u, which we already said u is negative x squared. And then it's minus, and then it's ln of 1 plus e to the u plus c. And then this is what your final answer will be for that one. Integration by tables can make things easy, but then also there's some difficult ones. Some of the basic ones we've done, we would have done this one a little bit differently. Okay, we could have done this a different way by multiplying the top and bottom by e to the x squared. And that would have canceled it out, and we could have done it with the ln, and we would have seen that this is what it would have came out to be. There's other methods to do this, but it's really going to be, table of integration is going to be the easiest way if you can figure out how to do it. All right, so I gave you your homework problems. You know what they are, and in the packet you'll have all the solutions that'll help you with the tables, what to set things equal to, and so on and so forth. And please, if you know how to do something, email me, contact me, and we'll make sure we can get it answered. All right, thank you.